Here's a story worth being careful about. A single prompt to GPT-5.6 reportedly produced a proof that closes a 30-year-old open question in convex optimization, and 2 independent groups say the key step checks out. That's a big claim. So let's separate what actually happened from the hype. Here it is, straight from the source. First, the math. The open problem, from the mid-1990s, was a lower bound. For a standard class of convex functions, how many function evaluations does any method fundamentally need? GPT-5.6's proof shows the answer grows on the order of d squared, where d is the dimension. That matters because an algorithm published 30 years ago already achieved that same d squared rate. So this proof closes the gap, showing that old algorithm was essentially optimal. Here's why a d squared bound is a big deal. As the number of dimensions grows, the work grows with the square. 10 dimensions needs on the order of 100 evaluations. 50 dimensions, 2,500. 100 dimensions, 10,000. Proving that no clever method can ever beat this quadratic wall. That's the kind of fundamental limit result that's genuinely hard to establish, and it had stood open for 3 decades. And the prompt itself was small, about 1,200 tokens over 2 rounds. It did 3 things. State the problem precisely, ask for a proof in the style of the classic Boyd and Vandenberghe textbook, and explicitly tell the model to flag any step it hadn't fully proven. Then the model reasoned, for roughly 148 minutes, nearly 2.5 hours of sustained thinking, before it produced the argument. The care in the prompt is doing a lot of the work here. Now the honest part, 2 independent groups have confirmed the central lemma, one using CVXPY, another with a custom semi-definite-program solver in Julia. And no counterexamples have turned up. That's real, and it's why this isn't just a rumor. But the original prompt hasn't been released, citing ongoing peer review, so nobody outside can fully reproduce it yet. And one verified proof, in a narrow domain, where tools already exist to check the answer, does not mean the model can do mathematics in general. So where does that leave us? This looks like a genuine, independently verified result in a specific corner of math, the kind where you can machine check the answer. That's impressive and worth taking seriously. It is not proof that AI has cracked mathematics broadly, and the unreleased prompt means the story isn't fully closed. The right response isn't hype or dismissal. It's exactly the careful scrutiny the mathematicians are giving it. That's the AI Daily. If you like the honest take, subscribe. Subscribe to BirenAI and ship smarter with AI. See you in the next one.